All right, it looks like I have the top of the hour on my clock, so we are going to get started. Hello, everyone. Thank you for joining me on this lovely Tuesday. So today we are going to be talking about using the GEOWEB Geocell system and how it can be utilized for both base stabilization in paved and unpaved roadways. So I'm your host, Sam Justice, and I've been with Presto for, nearly 10 years now. I came from the consulting world beforehand. I am a licensed professional engineer, and I have degrees in both civil and geotechnical engineering, and I work with the ASTM and ISO committees in the geosynthetic industry. So I'm one of the engineers here at Presto Geosystems, and we manufacture erosion control, stormwater management, and porous pavement products, all made in the upper Midwest of the United States. Through an extensive national and international distribution network, we offer both technical and site support, as well as free project evaluation services from our in-house engineering team, like myself. So today we are going to cover a couple key points that I want to make sure that you get a handle on. We're going to start with the benefits of using the GEOWEB Soil Stabilization System, including enhancing paved and unpaved roadways with the potential for using low quality fill, reducing your cross section requirements, and constructing roads over soft subgrades. And we're also going to talk about how the GEOWEB system can reduce the vertical pressures and reduce potential subbase movement. And then we're also going to touch on an interesting application of the GEOWEB system for stormwater management. So everybody is muted, but if you do have any questions, I urge you to put those in the questions tab in your GoToWebinar screen, and then I'm going to have a Q&A session at the end. So if I don't get to your question during the presentation, feel free to do that, and hopefully we have time for it at the end. So a little bit about Presto Geosystems, if you haven't heard of us. So we did collaborate with the U.S. Army Corps of the Engineers to develop the geocell technology in the late 1970s, and we've remained at the forefront of innovation in this market ever since. We offer more than just a product. We partner with our customers from the initial concept phase through construction to ensure you have project success. Our worldwide distribution network is highly experienced, not only in the geocell technology, but in other geosynthetics as well. And I really do believe that we have one of the most knowledgeable distribution networks available. So they are going to be able to help you both with your GEOWEB questions and the rest of the questions you may have for your project site. And our project assistance continues even after the product leaves our facility. So we operate in 4 main product areas when using the GEOWEB Geocells, which can be used for load support, what we're covering today, but then also slope and channel protection and constructing green retaining walls. We also offer porous pavement products where we have both a vegetated and a stone surface solution and lightweight reusable construction mats. Like I said, we are focusing on the load support application of GEOWEB Geocells, but if you have any questions about the other application types or the other products, please feel free to reach out and we're more than happy to discuss. So let's start with how the GEOWEB stabilization system can provide benefits for both unpaved and paved road surfaces. The GEOWEB system has 2 main characteristics, and the first one is going to be the cell diameter and cell size. So the cells come in 3 nominal diameters, 8.5, 10.5, and 18 inches. So basically a small, medium, and large. And then the cell heights are available in 3, 4, 6, 8, and 12 inches. So 5 different depths, 3 sizes. So the actual cell size and height that you choose are going to depend on your project specific details and your site conditions. Presto Geosystems offers a free evaluation service, which will include the written summary, supporting calculations, cross sections, and specifications, regardless of your project size. And this evaluation will determine the appropriate cell size and depth for your specific project. And really, to ensure project success, we recommend trying to stay away from things like standard graphs or tables, because each project is unique and the needs that it has are going to be very specific. And that's not really something that you can just show on a table and say, in this scenario, always use this size. That's just not realistic. Something else I want to point out is the ultrasonically welded seam, and that is what is going to be the connecting point for all of the GEOWEB cell walls. And it's crucial to the functionality of a geocell. The stronger the seam strength, the better the geocell's performance, period. The GEOWEB system is made from 100% virgin high-density polyethylene, HDPE, providing the strongest wall strength while maintaining semi-rigid ductile properties throughout. If a cell wall is too stiff, it can actually overstress those seams and potentially cause seam rupture, where it basically rips itself apart, obviously leading then to project failure, not something anybody is looking for. So the second main characteristic of how a geocell functions is going to be the infill material that you use. So there are four main types of infill that can be used with the GEOWEB system, and it's going to be based on your project type and the required protection you're looking for. So the infill types include coarse sands, topsoils, crushed aggregates, and concrete. So this type of sort of this range of material, I guess you could say, allows for the use of on-site materials. So you could potentially eliminate the need to import fill. And so we can work with you to review gradations of your on-site fill to determine the most cost-effective material. And we would include that in that evaluation service that we offer. So if you've done some excavation work, maybe you have a spoils pile nearby, something like that. If you want to try and reuse that material, we can help you review that and see if it's going to be something that's appropriate. And oftentimes it is, even if it is considered like a low quality material or a poorly graded material, that's usually still appropriate to use within the GEOWEB panels. Something I want to point out is going to be really critical for load support applications, and that's going to be the ATRA key, and it is the component that fully integrates the system. So the ATRA key connects the GEOWEB panels into a single web and significantly speeds up the installation time. It's made from durable HDPE, same as the panels themselves, so they are going to last the lifetime of the project. ATRA keys ensure that the panels will remain securely connected and that the GEOWEB system isn't going to fail under the anticipated loads. The specific engineering values of the ATRA key guarantee that the system's going to have complete durability over time, avoiding the corrosion that you'd see with something like metal staples or the failure from underperforming cable tie systems. And so it is just a single hand installation of the ATRA key. You can see how that goes in. There's perforated slots that you slide it right in, and it connects each of those panels together. And I just kind of want to give you a close-up of what that ATRA key does look like. And so you can see that there are what we call frictional barbs. And those are designed to enhance the interlock with the GEOWEB textured cell wall. So it actually helps make sure that the key isn't going to be accidentally turned and potentially opened once installation is complete. And so these barbs are a pretty recent improvement to the ATRA key, and collectively the features of the key provide that added protection against the three primary modes of mechanical junction failure, and that's going to be shearing, splitting, and peeling. And so additionally, we do evaluate the factor of safety for the ATRA key connection in our project evaluation calculations. And it's crucial that if you go through the process of getting a geocell evaluation, that the manufacturer, whether it's us or any other manufacturer, provides those supporting calculations to verify that the factors of safety for all of those primary modes of panel connection failure are met. And it's based on their specific panel connection method. We're the only one with this key. Everybody else uses a different method because this is something that we've patented for our system. So it is important that their calculations take that into account. And when I say other methods, it's going to be something like this. It's going to be metal hog rings, maybe metal staples. We also see plastic zip ties, cable connectors, that sort of thing. And so when we developed the ATRA key, our main goal was to provide that permanent connection between the panels that can be installed both cost effectively and without the need for power equipment like generators, hoses, pneumatic staplers, that sort of thing. And so based on the feedback from contractors and installers, it was crucial to offer a connection method that maximizes strength while being fast and, most importantly, safe for those construction crews. So this means no air hoses and the associated tripping hazards, and no equipment like pneumatic staplers or generators. And you can imagine the safety concerns when trying to connect panels using something like metal staples or hog rings, because it really just looks like an accident waiting to happen. I can just see somebody getting their finger pinched and ouch. So connecting the panels with these methods often also requires two people. I see 4 hands in that picture. And so that is something that both slows you down, and that's two people doing a job. Whereas with the Attrokey, it is a single person with no equipment. So it is much faster and much safer. There's no pinch points, anything like that. Okay, so the GEOWEB panels and all of our accessories, such as the Attrokey, are 100% made in the United States under strict quality assurance and environmental control processes, and they comply with all the requirements for the Build America, Buy America, and the Infrastructure Investments and Jobs Act. So if you are looking to maybe if you're getting federal dollars, you're going for grant money, or if you just have sort of like made in America requirements in any of your projects, all of our systems and all of our products do meet that. So it's just something to keep in mind. And like I said, the GEOWEB system is manufactured from that high quality virgin HDPE resin, and it has proven its durability over the past 40 plus years. So the GEOWEB panels do not contain any fillers. So there's no calcium carbonates, recycled materials, polymer alloys, things like that. So the GEOWEB system has been designed to last over 100 years, and we've done lab testing showing it can withstand up to 149 years before there's any carbon black degradation, and that's even with continuous 24-hour sun exposure, which is obviously not how the real world works, but let's, make those tests as extreme as possible. And so we really do stand by our data. We ensure that you're building with materials that you can trust. So definitely something to make sure you're checking when you buy these materials, that they are going to last as long as you need them to, and that they've been rigorously tested to show that they are safe and proper to be putting in your environment. All right, so I do want to do a little bit of a cross section so that we can all have the same sort of starting point of what this is going to look like when using the GEOWEB system. So you start with your subbase, whatever strength it may have, typically expressed as the California bearing ratio, the CBR. And then we're going to decide whether or not we need a geotextile, typically woven or non-woven, and that's going to be based on the system application and your subgrade type. And when we talk about woven geotextiles, I'm referring to what are called enhanced woven geotextiles, not slit tape wovens. And that is due to drainage. Slit tape wovens typically impede drainage. They don't allow water flow, or they significantly reduce the amount of water flow possible. Whereas enhanced woven geotextiles do allow for that free water movement. So that's something that's really important, because you don't want to have poor pressure buildup underneath the GEOWEB panels. That's not good for anybody. That's going to lead to issues down the road. So just something to keep in mind, but we will help determine what kind of geotextile would be necessary based on your project specific applications. Then sometimes you need a subbase of aggregate, and this is sometimes necessary, not always, but if you have maybe a very weak subgrade, a very saturated subgrade, or very, very heavy loads, if you're going construction loads, you're driving heavy cranes or something across this, a subbase layer will add that extra strength to help support that vehicle load. Not always necessary, but if it is necessary, this is where it would go. Then you put the GEOWEB panels down. If you don't have that subbase layer, the GEOWEB panel goes directly on top of the geotextile. If you don't have a geotextile, it goes directly on top of your subgrade. So hopefully you can see how this is sort of a bit of a mix and match, but you're sort of building this up like a layer cake, fitting in all of the pieces that you need for your specific project. And then you are going to put your infill material in. Again, that's going to be a granular material, coarse sand or aggregate. It could be topsoil or it could be concrete. Then, if necessary, you can pave directly on top of that. And so that is going to be asphalt, concrete, roller compacted concrete, paver blocks, things like that. It would go directly on top of the GEOWEB panels, and then you get to drive on it. Ta-da! So supported load, that's going to be things like vehicles. It's going to be footings for if you're trying to support water tanks is pretty common, footings for buildings, railroads, that sort of thing. So whatever your load is, going on top of that goes right there. And so like I said, Any of these pieces may or may not be necessary. This would be what the full cross section could potentially look like, but it gives you the idea of how everything goes down. And something about how the GEOWEB system works, if you are unfamiliar with this, it's going to be similar to the concept of how a geogrid works, but having the defined depth and the strength of the cell walls is going to be really important. So GEOWEB confinement operates by distributing the vertical cyclical loads. So when a vertical load is applied, the active earth pressures within the loaded cell pushes against the passive earth pressures in all of the adjacent cells, which then support that load collectively. So each cell aids the surrounding cells, if that makes sense. So as I sort of mentioned before, the GEOWEB system is particularly effective with sands, recycled materials, low quality materials that you might have on site, things like that, because it can quickly redirect the vertical loads horizontally. And that engages your cell walls and generates hoop stress within that loaded cell. And so the ability to disperse the load distribution angle is crucial for maintaining system integrity, creating what we call the mattress effect. So the strength of the internal seams, the panel connection method, which in our case is that ATRA key, and then the increased load bearing capacity through the mattress effect are key factors in enhancing the Geocell system's performance. So GEOWEB confinement prevents lateral shifting of the infill material, thereby eliminating rutting and controlling differential settlement. And so here you can see how the stresses on the subgrade look due to cyclical loading. So when a car or a vehicle drives over it. And so you have an unreinforced section on the left, and then the GEOWEB reinforced section on the right. So the unreinforced section shows a pretty typical stress distribution curve with the highest stresses right at that interface between the tire and the subgrade. Excuse me. So the load is dissipated over a typical about 45-degree load distribution angle. With the GEOWEB reinforced section, you're actually eliminating the highest levels of stresses, in this case, the red and the orange levels. And you're spreading out the load significantly wider than that 45-degree angle. So by spreading the load over that wider distribution angle, the stresses reaching the subgrade are really reduced. So you're controlling deflection, rutting, and differential settlement. A typical rule of thumb that we offer with the GEOWEB system is that it can reduce your subgrade stress, reaching that subgrade by about 50%, which is significant. And so the project evaluation service that we offer, again, based on your site-specific conditions, will show that actual stress reduction. So that's definitely something that can be really important if you have buried utilities or things like buried water tanks. A lot of those have maximum allowable pressures on top. So we can use this and show you that that maximum pressure is achieved and that you're going to have an adequate system. All right. How about we actually click through? There we go. And so I want to talk a little bit about some of the testing and the research that we've done with Geocells, just because I think it's really important to know that we aren't just throwing this out in the world and saying, hey, good luck. We've done the testing, we've done research, we've been doing this for longer than anybody. We are trying to make sure that what we're putting out there is really going to be the most appropriate for what you're trying to achieve. So we've done quite a bit of testing, but the one that I'm going to talk about today was research conducted at the University of Kansas under the direction of Professor Yi Han, who has been conducting research on geocells for over 20 years. He's one of the foremost researchers in this industry. We've also have Ben Lashinsky from Oregon State, who completed his PhD thesis on geocells conducted with finite element analysis. And then we also have Hai Huang from Penn State, who provided the smart rock technology, which we'll talk about in just a second. So we aimed to utilize a lot of new recent technology to verify the stabilization benefits of geocells. And so each test was equipped with earth pressure cells and smart rocks. And that's going to be that yellow sort of teal rocks that you see in the smaller photo there. So each smart rock contained a motion and vibration sensor capable of recording all rotation, translation, and orientation of the rock, no matter where it's placed. And then the earth pressure cells were employed to measure the actual vertical stresses and displacements at the interface between the surface and the subgrade. And so the cross section included an enhanced woven geotextile, a 6-inch deep GEOWEB panel, and then an 8-inch aggregate surface layer. So to assess movement under cyclical loads, smart rocks were placed inside the GEOWEB panels, 4 inches above the GEOWEB panels, and 4 inches below the surface. And so we have the wear surface, that really thick wear surface, so that 8 inches above the panels, to evaluate the movement when the material is not confined. So that's basically free rock above the panels. It's considered unconfined, and then the material within the panels itself is considered confined. So that those smart rocks measure particle translational acceleration and velocity in all directions. And so the objective was to confirm that the GEOWEB stabilization controls movement not only within the cells, but also above the cells. So here you can see they're holding a smart rock. So it's actually quite large, as you can see in the hand. And then it is measured in 3D space. So as the rock moves, turns around, it gets measured in that movement space on the computer so that you can see what the actual movement level is. So a couple of slides that we're going to go through here. I know you can't read the actual graphs super well, but just seeing the picture is going to be enough to give you the idea of what we're looking at. So this slide illustrates angular velocity, which measures the speed of particle rotation. So the two graphs on the left-hand side depict the placement of the smart rocks in the middle of that 8-inch surface layer, while the two graphs on the right-hand side show the smart rocks that are positioned within the actual GEOWEB panels themselves. And so you can see the difference between the control section, basically the unreinforced section on the left, and then the GEOWEB stabilized section on the right. And it's really actually fascinating to note that the stabilization section not only controls movement within the cells, but it can also influence the unconfined layer above the GEOWEB panels. So something similar here, this shows angular acceleration. So how fast the particle moves when it is subjected to those cyclical loads. So again, just like we saw before, the GEOWEB stabilization is on the right, and then the unstabilized area is on the left. So you can see how much more stabilized it is with the GEOWEB panels. So it's really a pretty remarkable and stark difference with the panels included. You can see that. And then last one here. So the tests really clearly demonstrate that the GEOWEB stabilization significantly reduces the particle acceleration and velocity, both within the cells and in the unreinforced area above the cells due to that stress reduction. And this stabilization effectively minimizes particle movement by providing lateral confinement, reducing breakage, vertical compression, attrition, and lateral spreading. Lots of different things. But basically, it significantly improves the performance of the aggregate. By controlling particle movement and rotation, maintenance and rutting for unpaved surfaces are decreased, and a more stable base is provided for paved surfaces, leading directly to cost savings and lack of pavement degradation. So that's sort of the key. The GEOWEB system works, and it works by reducing your maintenance costs, so you know that you're going to have a roadway that lasts as long as you need it to. All right, so let's focus now on the GEOWEB system and providing base stabilization for your roadways. We're going to talk about project examples. People like to see these things happening in the real world. And we're going to start with unpaved surfaces, so basically aggregate surface roads. So this project here involves constructing an access road to an an energy plant. It was an emergency access road. So the original design included a geogrid, but due to the low subgrade strength and some really heavy rains that had happened, the initial 1,000-foot length of installed geogrid had failed when heavy equipment attempted to access the site for construction. The project engineer, who was familiar with the GEOWEB system, contacted us for a value engineered design solution. This was an access road, and it spanned a couple miles, located through a swampy area in South Baton Rouge, Louisiana. So you can imagine, very swampy, very wet, and as this shows, it had a 1% CBR, which is a very, very soft CBR. So the 1,000-foot section of installed GeoGrid was removed, and it was replaced with a layer of 4,800 pound per foot enhanced woven geotextile, which is a relatively strong woven geotextile, and then the medium size GeoWeb panels 6 inches deep. And so the original GeoGrid design had included 2 layers of GeoGrid and a total of 16 inches of high quality crushed aggregate. However, we were successfully constructed using a lower quality aggregate sand mix that had been on site. So that's where that low quality aggregate ability comes in. It didn't need to be an engineered stone. It was able to be what they had excavated from on site and had an 8-inch cross section. So this was an approach that utilized a lower cost aggregate sand mix and reduced the cross section by 50%. So you can see sort of double savings there, lower cost material and less of it. So really helpful. It was a great value engineered solution. And here you can really see the flexibility of the panels, very evident how it's being installed to accommodate curves in the roadway with no issues. So these are very flexible. They're not rigid panels, so you can go around curves, up and down some dips or grade variations in your roadway, that sort of thing. And so this particular roadway had numerous curves that had to be negotiated, and really highlights the importance of that panel flexibility. And we can be on site to assist the contractor in their installation. So it's really a benefit if they've never done it before. Maybe they're a little nervous. We can come on site, make sure everybody feels comfortable in doing the installation. And really, once you get your hands on it and once you see it on site, it becomes quite intuitive how it's put together. But having that on-site presence from the manufacturer can really be crucial in training your contractors in the proper technique for speedy and efficient installation. And in this case, the infill was simply dumped onto the unfilled panels and then spread out using a bulldozer. So this infill material, like I said, it was that low quality aggregate sand mix, really saved the owner a significant amount of money because it didn't have to be engineered stone. It didn't have to be trucked in from a faraway location. They were able to use something significantly closer. And something to sort of point out, geocells and geogrids start with the same concept of how they function, but geogrid performance is directly related to a high friction angle of the info material. It's why they need that high quality engineered stone. So basically, the higher that friction angle, the better the performance a geogrid is going to have. And that really contrasts with geocells and with how the GeoWeb system functions by being able to utilize that low quality aggregate, and it still performs just as well, still has that the strength capacity. We talked about how it functions, where it's confining the material, it's spreading that load out with the hoop stress, creating the mattress effect, all of those things. So it's really a really substantial advantage, especially in terms of cost and aggregate savings. And then so here you can see how that final road construction is going, how they filled it in around the corners. You don't see the GeoWeb panels when it's filled in like this, so you're not seeing that plastic material. You do just see the aggregate surface of the roadway. So you know that it's gone in well, and now you can drive on this directly, including heavy construction equipment. So definitely a great project. So this was another project. This was for a sawmill up in Western Canada. In the spring and the summer, snow melt and rain had caused flooding in the area and created soft, challenging ground conditions. Drainage issues and rutting not only created unsafe conditions for the workers, also wreaked absolute havoc on the machinery, resulting in increased equipment maintenance. So the owners were looking to find a long-term soil stabilization solution for the roadway, laydown areas, and machinery areas. The owner had used the GEOWEB system before, so they were already familiar with its benefits, and so they reached out to us as an option for this logging yard. One of the great design challenges for this particular project was a plan to manage stormwater and snowmelt. The engineer had called for large rock initially to help promote that stormwater infiltration, and had it sort of sandwiched between layers of geotextiles to hold that rock in place to try and let that stormwater happen. It was becoming a whole thing. So we were able to come in, offer our value engineered solution. In this case, it was a 6-inch deep GEOWEB panel that was installed above a single layer of a geotextile to confine that crushed aggregate infill and provide that strong reinforcement layer to support frequent and heavy vehicle loads. We also limited the fines within the GEOWEB material to help promote that drainage. So in this case, we said the fines content, so your silts and your clays, had to be less than 10%. This makes sure that you have that really good free drainage through the void spaces of the stone. So in this case, they did need an infill to be a little bit more engineered because they had a specific goal in mind, drainage. So that's something to sort of balance out. Maybe you have on-site material that you could use, but you don't exactly know the quality, you don't know the gradation. There's a lot of fines to it. If you're not worried about drainage, if you're in a very arid environment, or you have other drainage infrastructure set up on site, great, use it, 100%. But if you know that drainage is a concern, if you know that stormwater management is something that you need to prioritize, that's something that we can focus on, and it will influence what type of infill material might be the best choice. So just something to keep in mind. So as I mentioned, the infill material had to be use limited fines to help promote that stormwater flow and the infiltration capacity. And that was another reason to use the woven geotextile, an enhanced woven geotextile, because it does allow for water to flow freely in both directions without clogging or binding. A non-woven geotextile would get clogged very easily, and a slit tape woven does not actually allow water movement in both directions. The water gets basically trapped by the geotextile, creates potential pore pressure buildup issues. So just something to keep in mind. And like I said, we can help you determine what geotextile is going to be the most appropriate for your specific site needs. So through the confinement of the infill material, the GEOWEB system eliminates rutting at the surface, creating a nice smooth platform on which machinery can operate, and it's going to significantly reduce your maintenance costs over time. The owner and installers of this particular project were pleased with the ease and speed of installation thanks to that Attra key connector that we had talked about, and by the offer of on-site installation support by the manufacturer, us. Okay, another project here. This one dates back a couple of years, gosh, probably close to 15 years now. So the customer had reached out to one of our distributors to explore options for rehabilitating and upgrading a failing access road. The rehabilitation was necessary to withstand the demands of a new plant expansion. So a new plant was coming online and being commissioned. And so the original access road had served as a secondary route for regional facilities, but had over time become impassable due to spring and summer rains, due to lack of maintenance on the road. And now that a new plant was coming online, more traffic was going to be on a road that was already in bad shape. So they needed to basically upgrade it and get it ready for that new plant to come online. So one challenge was to keep the road operational during the initial subgrade preparation and to stage reinforcement materials and the gravel infill material before closing the road for repairs. So the execution plan required the road to be closed for less than 2 weeks. So a very, very tight schedule. So it was very important that everything be staged and prepared so that as soon as the road was closed, work could get started right away. So the project was successfully completed as designed during a very wet construction season. So here you can see that roadway before the installation had begun. The subgrade was wet, basically saturated, had a CBR of around 1.5%, so pretty low. Definitely not something you're hoping to drive construction vehicles on. The materials were staged on the side of the road, which was crucial for efficient installation as it prevents handling the material multiple times and it keeps the process moving smoothly. We collaborated with contractors on that material staging, and it was further complicated by fiber optic lines running down one side of the road, which restricted the contractor's access to that area. And so we worked with our distributor and the project owner to provide that recommendation that ensured a stable road surface and it could be installed within the 2-week time frame. So even in challenging projects, we are going to work with you, work with your contractors, work with your project owners. We're not just talking with, the engineer and saying good luck. We are working with everybody involved in the process, making sure that everybody is comfortable with it. It's going to meet all of the needs that are arising on site, meeting all of the challenges that are arising on site, making sure that this is going to be the right, best solution. So here you can see those panels being connected with those ATRA keys. For low subgrade CBRs, we typically recommend looking at factory seaming your geotextile underneath. It's going to save a significant amount of installation time in the field. Basically, it replaces the need to overlap your geotextile because it's seamed so that the different panels aren't going to come apart. Little bit more upfront cost, a little bit less installation costs, so sort of balances out in the end. But it's just a recommendation that we can offer, not strictly required, but they did it in this case, worked out really well for them. So we do follow AASHTO M288 specifications when using geotextiles for the amount of either overlap that they have to do or the strength of the factory seaming that they have to have. So just something to keep in mind. We do follow AASHTO and FHWA standards for all of our installations so that you know that you're getting basically a solid product installation. Here in this slide, you can see that the GEOWEB infill is being stockpiled on the left side of the road, and then an excavator is filling in the 2 lanes along the roadway and then transferring the remaining stockpiled material into the GEOWEB panel. So that sort of sequenced construction was really important in this particular case. So as mentioned, there was that fiber optic line that ran down the right side of the road. So that made it completely off limits. No one could, drive over there, work over there, that sort of thing. Then you can also see the truck dumping the material onto the GEOWEB panels right after that fiber optic location was over. So once we didn't have to worry about that anymore, it became much easier to try and get everything in place. We used some bobcats and excavators to completely move all of those materials from the stockpile, and then a dozer was used to finalize the grading of the road. In this case, it was a dozer that was equipped with that GPS sensor at the bottom of the dozer blade to help ensure that consistent final wear surface. Pretty common nowadays. It was kind of neat the first time we used this. Like I said, this project's a bit older, but pretty commonplace nowadays. So for this project, we actually recommended a 3-inch wear surface over the GEOWEB panels. Usually it's not quite that thick. And that was just going to be due to the number of passes. It was going to be a very busy road during the commissioning of that report. So the wear surface, like I said, can be made thicker or thinner on a roadway, and it's really on case-by-case basis, something that we can help you determine. If you have some very heavy loads, such as reach stackers, if you're in maybe a port environment, having a thicker wear surface, maybe 4 or 5 inches, is going to be a little more applicable. If you're on a residential road or a low impact road, something you're not going to drive on very frequently, you could go as low as 1 inch. So pretty wide variation, and we can help you determine what that's going to be. But here is that completed road, finished on schedule despite some unfortunate weather challenges. So this project actually involved installing about 1.3 million square feet of GEOWEB panels in just 2 weeks. So even with that weather challenges, we were able to get a significant amount of material in the ground. And the GEOWEB crew was able to go about 3,000 to 4,000 square feet of GEOWEB per hour with a team of 4. So that gives you a sort of general idea of what the installation rates can be. Imagine it's going to be a little bit slower when you start out if you're unfamiliar with it, but once you pick up and get moving and you have a pretty good clip going, you can get quite a bit of material in the ground quite quickly. So here's another application. This is actually slightly different, but it's for road shoulders. So the GEOWEB system can support all types of highway traffic loading. So anything from cars to semi trucks, emergency vehicles, that sort of thing. And so it actually makes an excellent choice for extending and stabilizing your road shoulders. The GEOWEB panels can be filled either with pure aggregate or with what we call engineered fill, which is a mix of aggregate and topsoil together. And that mix allows for a vegetated surface. Grass is going to grow, but then it can still support your vehicle load. So it's a great way if you don't want to or can't put more hard surface roadway in, you can't put more asphalt or concrete. This is a great way to still get vehicle load support capabilities, but not necessarily have it be, look like a roadway. And so the majority of shoulders that we do are going to be pure aggregate just because that keeps it pretty simple and clean. This was a project for a welcome center on Interstate 75 down in Florida. The engineer had contacted us based on needing rut control. You can see the problems on the left-hand side photo there. That's digging a pretty deep hole that they needed to try and both fill in and then prevent from happening again. So the trucks, in this case, were causing it because the corner of this roadway wasn't adequately built, so it didn't have adequate turn radius for the trucks. So they were just constantly going off the road, digging into the grass, creating these ruts. And so basically the GEOWEB system was going to extend the curve of this road and try and make sure it became a little bit more maintenance free. So this is what that looks like. It's basically extending the road up and around the corner. So it's been performing really well. It's been about 5 years now that it's been in place. No major maintenance issues. Visual maintenance is really what we recommend. Maybe once a quarter, just go through and see if you start seeing any of the GEOWEB panel from the aggregate. You just place a little bit more stone down and you're good to keep going. And so one of the advantages of using GEOWEB for road shoulders like this is that it is very cost effective way to prevent that rutting and without having to constantly go back and do that maintenance and try and keep fixing all of those, minor locations. One of the advantages of using the GEOWEB system is that it does have the ability to allow for that water flow, like we mentioned in one of the previous projects, making it applicable for a permeable or a porous pavement. So this is where you're going to want to make sure you limit that fines content, 10% or less. Of fines gets you that good open space, that void space between the stone, which is that where that water is going to flow. So this is a great way if you know that you have porous pavement requirements or you've limited how much hard surface pavement you're allowed to have on site, that sort of thing. And so we can help you determine what that's going to look like, how to meet your local regulations, how to talk to your permitters, that sort of thing. And so we really can help make sure that everybody is comfortable using this as a porous pavement. I know that there are some sort of outdated regulations out there that say aggregate can't be porous pavement, or we've heard some weird stories. I'll say it like that, where people are claiming that putting in a stone parking lot or something doesn't count as a permeable area. And so we are able to help you give those supporting calculations, meet those regulation needs, make sure everybody feels comfortable, that sort of thing. All right, gotta move a little bit faster here. Okay, so like I said, permeable parking lots, you can get that in there. You can help potentially reduce the amount of drainage equipment that you need. It is going to depend a little bit on what your subgrade base is. Clay bases obviously don't allow infiltration quite as much as sand bases do, but all of it works together. You potentially have the ability to reduce your stormwater pond size because you can actually store that water in the aggregate base of the GEOWEB system and let it infiltrate naturally rather than having to collect it and moving it to a stormwater base. Something we can help you determine. We have those sorts of projects out there, so we can help determine that. There is no one right way of doing it or hard and fast rule about it, so it's hard to give specific numbers, but it is something that our evaluation calculations can show and support. I've mentioned a number of times, these are our project evaluations where we follow, in this case, AASHTO methods for determining what the cross-section is based on your vehicle load requirements, what your subgrade strength is, that sort of thing. Basically, here is where I mentioned that, where it's showing that we meet the adequate factor of safety for all the different types of potential failure. And that's going to be your wall strength, your seam strength, that ultrasonically welded seam, and your mechanical junction, in our case, the ATRA key. So it's showing that we meet adequate factors of safety for all of those. And this is something that you really want to make sure you get from your manufacturer, whether it's us or anyone else, that this is going to meet all of those factors of safety, that you're not going to have potential failure somewhere down the line because something wasn't strong enough. That's really what we want to try and avoid, because that's going to just lead to project failure. You're going to rip a big hole in your panels. Nobody wants that. Here is that stress reduction I've mentioned a couple times as you go down, what the vertical stress on your subgrade is. So you're going from the surface at the top there and reducing your stress as you go down based on the depth of the system and what GEOWEB panel you choose. And then we also can evaluate the cross-section over the lifetime of passes using a Giroud-Hahn method modified specifically for the GEOWEB system. And it shows how the GEOWEB system can reduce your pavement cross-section depth compared. Blue is unreinforced, green is reinforced with the GEOWEB system. And so based on the number of passes, in this case, a million lifetime passes, you can see a significant total thickness reduction when using the GEOWEB system. Like I've mentioned a number of times, the CBR, the California Bearing Ratio, is how we typically measure the strength of your subgrade. But if you don't have that, maybe you've done standard penetration tests, you've done, so you have your blow counts, maybe you've done shear strength testing. But if you haven't done any geotechnical testing, especially for small projects or residential projects, that's not always done. That's totally fine. We can sort of estimate it based on your visual identification of what it looks like, and then our experience with what these sorts of things look and feel like. So we can help give an estimate of what the CBR value is going to be and how to determine what your cross section is. All right. I'm going to go through this very, very quickly, and I apologize for how much my time has been off, but we're going to talk about using the GEOWEB system under paved surfaces. So it's going to be essentially the same benefits and functions as we just saw for the aggregate surface, but you're going to put a asphalt or a concrete road on top. This is something that we see a lot in terms of like roadways of smaller projects going through towns, but also highways and parking lots, things like that. In this case, this was a road in Middle Ohio. They wanted to replace their asphalt road, which had been cracking and failing, but they needed a stronger base. So they put the GEOWEB system in underneath it. It's still a very thin base. It's still just going to be the 6-inch deep GEOWEB panels. And then you pave your asphalt directly on top of that. So you can see it filling in with the stone, just as we had seen before. Fill everything in, fill it with that stone, and then you pave directly on top of that. It's going to be your standard asphalt equipment, asphalt paving installation. None of that part of it's changed. So you don't need any specialty equipment, specialty training for your contractors, anything like that. Once the GEOWEB panels are down and in the ground, you treat it like it's your standard subgrade and you're able to go. And really what it's doing, we can all sort of imagine, or not even imagine, I'm sure we've driven over it, maybe even this morning, those sort of alligator cracks where it's just tearing itself apart. Lots of ruts happening, random sinkholes happening in there. All of that's because you have a weak base underneath your paved surface. And that weak base is leading to a weak asphalt. So it's going to keep cracking from differential settlement. As this material underneath gets saturated, it's going to settle, things like that. And so putting in the GEOWEB system really reduces that potential. Everything is going to be held in place and confined very well with the GEOWEB panels. And then when you pave on top of that, you now have a smooth, strong, stable base leading to a roadway that isn't going to fail because it doesn't have any of those issues underneath. We do follow the AASHTO method, determining a roadway structural number when doing pavement like this. And so this was what the AASHTO number was with no GEOWEB reinforcement. So it had a structural number of 3.84. And this was based on the number of easels, so the number of passes over there, and on the different levels, level coefficients based on a cold mix asphalt and then an aggregate base layer. And obviously it was failing. It wasn't adequately designed, and every time spring came by and there was the freeze thaw method and water came through, it just kept getting worse. So we were able to add a GEOWEB layer, and there is a GEOWEB improvement factor that goes into it, giving its own structural number, so that gets added to the overall layer structural number. But it also becomes significantly thinner with the strength of the GEOWEB system taking place of a much thicker aggregate layer, but still achieving a higher structural number, therefore a stronger base for your roadway. So your roadway is going to have a much better chance of actually staying in place. And so this is what that cross section looked like for this specific project. But so it's a enhanced woven geotextile, the GEOWEB panels, a little bit of an overfill of the panels, and then paving directly on top of that. And so it was a locally sourced, low quality infill. So you're not bringing in that expensive stone. You can use what you've excavated on site, and then you can pave just as you would normally. However thin or thick your pavement layer is, that doesn't have to change with the GEOWEB system. The GEOWEB system is supporting what you want in the field. And here you can see how that is laying down. Pretty standard, everything we've talked about. That geotextile goes down, the GEOWEB panels on top of that, filled in with the stone, and then you pave directly on top of that. This picture is about 7 years of service life with the GEOWEB panels underneath it. It's significantly reduced maintenance, frost heaves, ruttings of the roadway, all because the GEOWEB system mitigates that differential settlement and provides that mechanically stabilized base layer with that really improved stiffness. And so now this roadway is going to perform really well for decades. And, we're doing this sort of thing all across Canada and the US. We're doing, hundreds of kilometers, hundreds of miles of roadway like this every year. Another similar type of project failed, in this case, a very small location of asphalt. And so they wanted to just replace a small little thing, and that's totally fine. Rip out the failed asphalt. You're going to put the GEOWEB system in underneath it, and then put new asphalt on top. So it doesn't have to be a big project. It can be very small. It can be very localized, and the GEOWEB system still gives you that benefit. It doesn't have to be, hundreds of miles of roadway to be a benefit. It can be a very small location. This was another project. This was actually for the BNSF Railroad out in Washington State. And so this was an auto storage yard. So it was going to have some very heavy loads, and it had a pretty weak subgrade. And they wanted to try and reuse the material that they had on site. And so again, staging was important. So that was something that we were able to help with. Having our materials on site is a really great way to stage all of everything without needing to take up a lot of space, and you don't have to bring in that expensive engineered fill. You can use what you've excavated on site. Like I said, about 3,000 square feet an hour is a pretty typical installation rate. Once you get going, that's something that you're going to see a lot. So it's a really pretty good clip, and you'll be able to do that. So the bigger projects, you're going to move quite fast. This particular one, they actually surveyed and staked each corner of the panel. That is not strictly necessary. This was something that the railroad required for their installations. So we can help you meet your project-specific requirements, no matter what they are. So don't worry if you feel like, I'm in a really unique situation and I don't know if you'll be able to help. I promise we can help. We've done all sorts of unique things to try and make sure everybody is comfortable with how everything's going down. So definitely reach out if you know you have anything that's going to be, this is a little strange. How do you feel about it? And we're going to say, done, we got it. And here's what that is going to look like. Everything going in, all of the infill material going in. In this case, they had a number of dump trucks going at once, number of bulldozers putting everything in place. But then they paved concrete right on top of it. So you don't even know the GEOWEB system is there. You don't know that that base is there, but it is very strong. It's very stable. It's very in place, not going anywhere. You're not going to have that differential settlement. And now they have this huge auto yard that they can put very heavy equipment on, or cars, and it's not going to have all of those issues. It's not going to have a lot of maintenance. So really great final surface solution. Like I said, we do use the AASHTO method for this, so you can see what types of calculations, getting that structural number like I mentioned. And there we go. So I got there in the end. So the GEOWEB load support system really enhances your projects by providing that more stable and durable surface for your unpaved areas, reducing maintenance and repairs, or for paved surfaces, it's really reducing the pressure on that subgrade. It's minimizing differential and long-term settlement to help extend your pavement's lifetime. The use of low quality aggregates, sands, on-site materials, recycled materials is a really great benefit. And you can reduce that stress on the subgrade and reduce the total thickness of your pavement. And really, we do offer that comprehensive system solution, and the recommendations are tailored to your site-specific project details and conditions. We recognize that each project is unique and it demands a tailored solution based on your specific site conditions. The GEOWEB system can be integrated into projects to offer a more stable, durable, and adaptable solution. It is a comprehensive system designed for easy installation and peace of mind. We collaborate with you throughout the entire construction process to ensure you have total project success. All of our support is complimentary. It's free. We offer it completely, and we provide value engineered solutions weekly for projects around the globe. And we also understand that the GEOWEB system might not be the right solution for every project. And if that's the case, we are going to help with our distribution network, who is well versed in all types of geosynthetic solutions. So even if we aren't the right solution, we can still help. We still want you to have a successful project. With over 40 years of expertise, we can guarantee that each shipment meets or exceeds our specifications, ensuring that you can build with materials that you trust. We deliver quality without any disclaimers or concerning fine print, delivering certainty with every project. All right, I made it in right at the end. So thank you so much for taking your time out of your busy schedules to join me today. My contact information is here. I definitely want you to reach out to me. A little bit of housekeeping. If you watched live on Tuesday the 17th, you're going to get an email from GoToWebinar with the link for your PDH certificate. You'll get that by the end of the day. And that's how you're going to get your PDH. And then by the end of the week, you're going to get another email, this one from Presto Geosystems, with information for the webinar dashboard. And so this webinar was recorded, but we put that up on the dashboard. There's going to be extra materials on there that you can use, specifications, details, that sort of thing that you can download and use for your projects. Also, our previously recorded webinars are up there, and you can watch those webinars and earn PDH certificates as well. So that email is coming by the end of the week. So 2 emails, GoToWebinar, Presto Geosystems. As always, check your spam folders if you don't see anything, but reach out to us if you do have any questions about that. And definitely reach out to me if you have any questions, or if you have a project that you think might be a good fit for the GEOWEB system. I'm always happy to see what's happening out there in the world. I love talking about projects with people, so I want to hear what you're working on. There are some questions that came in through the Q&A. I'm going to keep recording, but if you have to hop off, I totally understand. And I appreciate the time that you spent with us today. The Q&A session is going to be recorded. And so if you want to get on the webinar dashboard in a couple of days and just skip to the end and get to the Q&A, totally understand. Great option. All right. So let's see about some questions here. So I'm trying to maximize these a little bit so I can actually see them all. So how does this system perform in sloped road solutions? So that's a great thing. So a lot of these pictures showed essentially flat roadways, which is pretty common. 2 to 5% grade is what you would expect most roadways to be, but it's not all that there is. You can have steeper roadways going up and down slopes, especially access roads. sometimes have some pretty steep grading requirements, and you absolutely can use the GEOWEB system for that. So up to around 12 to 15% grade, you aren't going to need any sort of anchorage. The GEOWEB system is going to be, you can just lay it on the ground like everything that we showed today, and it's going to stay in place. It's not going to slide. If you have a steeper slope, if it's more than about a 15% grade, we're going to start wanting to look at anchorage options, something to hold the panels in place to that slope as you drive on top of it. So what that's going to look like is usually going to be stake anchorage, but it could also use what we call a tendon and crust anchorage system. We didn't cover those today, but those are really common options for slope protection, and so you can use them in the load support applications as well. And so really we can get up to about a 33% grade roadway, depending on the load, depending on your project specific factors, is going to say whether or not it's 100% going to work or not. But we can get quite steep. So I don't want that to deter you from thinking that the GEOWEB solution might be something that would work for you. Definitely reach out and we can discuss it, and we would show those anchorage calculations. We would give our recommendations of what that would need to look like. We would include that in that evaluation package so that you would have full confidence that the anchorage is going to support the panels and the vehicle loads on top of it. So great question. All right. Let's see, another one. Let's see, how is it comparing cost-wise? So yeah, cost is always a big thing. I know everybody, everybody's got to consider cost at the end of the day. And so it's something to consider more holistically than just the pure material price. Because yes, a layer of GeoGrid is going to be cheaper than a GeoWeb panel. But you have to consider things like your material costs. So we talked about how the GeoWeb system can use lower quality materials or even on-site materials compared to high quality engineered stone. So you're going to have a lower cost of your infill material. You're going to have a thinner overall cross section. So you're going to have less material that you need to put in. So you're going to have a lower cost there. It is typically a faster installation than a very thick cross section. So, a 16-inch two GeoGrid layer section versus a single panel 8-inch GeoWeb section. So it's going to be a faster installation time. And you're going to have less lifetime maintenance costs. So you're going to have less material costs, less installation costs, less transporting costs, but potentially a higher GeoWeb material cost. So something to consider. We just sort of urge you to reach out and let us know what you're looking at, and make sure you're thinking about it, like I said, holistically. You can't just solely compare the price of a GeoWeb panel to a geotextile because they don't have the same total section. So just something to consider. Unfortunately, I can't give you a set price because, again, it is that really project specific thing. So I understand. Number of questions about using this as drainage. So either putting in a specific drainage infrastructure under the panels or trying to have it drain naturally. Number of questions about that. So yes, great application for the GEOWEB system is allowing that drainage. If you have a already well draining site, maybe you're over a sand material, something that drains very quickly, very well into the groundwater system, you typically can just put the GEOWEB system right on top of that and allow the water to flow from the top, go through the GEOWEB panels and then into the groundwater. There's no impediment there. It just flows very freely. It's great. If you have a site that doesn't drain well, it's very clayey, there's already a very high water table, so it can't go into the groundwater very quickly, that sort of thing, it might be best to include additional drainage infrastructure. What you can do is you can put drainage pipes underneath the GEOWEB panels and collect that water and take it off site. You could just have a thicker section of the GEOWEB, so you have more aggregate, and store the water within the aggregate of the GEOWEB panels. So let it drain very slowly into the groundwater system. It's not ponding at the surface. It's not collecting at the surface. So you're not seeing, just buckets of rainwater staying at the surface. It's still going down below the surface. It's just being held within the aggregate, within all those void spaces of the aggregate in the GEOWEB panels, and very slowly percolating down into like a clay subgrade is what I'm thinking of. So that is an option. It's a very valid porous pavement option to do it that way. So there's a number of different ways to include drainage or to highlight drainage, focus on it with the GEOWEB system. And that's something that we would need to talk about on a very case-by-case basis, because what you need is very unique to your project, but also where you are is going to really determine what type of regulations you have. And those are very, very important to me, but also very picky, very finicky. A lot of people are, when they have to meet those stormwater regulations, have very specific methods they have to follow to beat that. Very detailed checklists. And so we can help you with that. We are well versed in that. So I urge you to reach out if you do have those sort of drainage specific questions. Let's see. I'm wildly over my time. So I'm going to do one more question, but I really urge you to reach out and email me directly if I didn't get to your question or anything like that. It's about the idea of what you're delivering to site. So I mentioned staging a number of times. What does that look like? So all of our materials are delivered on a pallet. You can either pick them up from a local warehouse and take them to your site, or they can be shipped directly to your site. And so they come on a pallet. And so they can stay on a pallet during staging, or you can take them off the pallet and make a big pile of everything and pick it up later. But the GEOWEB panels do come what we call collapsed. So they're not on a roll like a geotextile would be, because they do have that defined depth. You can't put them on a roll. So they are basically collapsed. They're folded up really tightly. They're about, I'm gonna get this wrong, a couple feet wide by about a foot deep, and then the depth of the panel. So they're smaller bundles basically, and then the bundles are stacked up on a pallet and then attached to the pallet. And then when you're ready for a GEOWEB panel, you take that bundle out, snip it open, and then expand out the GEOWEB to the full size that you need it to be. And so that's how it's basically delivered. It's delivered, all of those bundles collapsed on a pallet, and then they're shipped to your site. And so it's really easy to stage those. You can put the pallets at certain locations around your site, or like down a roadway sort of thing. And then leave them on a pallet so they're small, confined. Here it is, ready to be staged. And that way you don't have to, be constantly running back and forth to some sort of far away staging location, collect the materials, and come back to where you are. So I hope that makes sense. We have photos of what that looks like if you are curious of what a collapsed bundle looks like, that sort of thing. But thank you everybody for attending. I apologize for going a little bit over my time. Definitely please reach out to me. I would love to answer all of these questions and talk about projects, and just see what you guys have going on out there. And I hope that we see you at future webinars. So keep an eye out for emails for registration for those. We have webinars about every 2 weeks. So definitely keep an eye out. We have lots of good topics coming up for the rest of the year. And I hope you all have a wonderful rest of your day. Bye.